In today's video, we're going to explore the concepts of speed and velocity and understand how to calculate each one accurately. As we discussed in a previous video, quantities in physics can be categorized into two main types: scalar quantities and vector quantities. Scalar quantities possess only magnitude, which means they express the size or extent of something without any information about direction. On the other hand, vector quantities contain both magnitude and direction, giving us more detail about the nature of the motion or force involved. For instance, speed is classified as a scalar quantity because it simply tells us how fast something is moving without mentioning the direction. Examples of speed include a person running at 4 meters per second or a plane flying at 250 meters per second. These values express how fast the objects are moving, but not where they are headed. Velocity, in contrast, is a vector quantity as it also includes directional information along with speed. For example, if someone is cycling at 6 meters per second towards the east, or if a train is traveling in reverse at 55 meters per second, these are both examples of velocity because they specify not only how fast the object is moving, but also the direction in which it is moving. A common mistake in examinations is to confuse speed with velocity, so it is crucial to be completely confident about the distinction and avoid mixing the two up. Similarly, another pair of physical quantities that you need to understand clearly are distance and displacement. Distance is a scalar quantity as it only tells you how far an object has traveled, without specifying any direction. Examples include 10 meters or 40 miles. Displacement, however, is a vector quantity because it describes how far and in which direction an object has moved from its original position. For instance, if someone runs 40 meters to the east or if a ball falls 2 meters downward, these are cases of displacement because both magnitude and direction are involved. To help illustrate the difference between speed and velocity, let us consider a train that is traveling across a bridge. Suppose the bridge is 550 meters long, and it takes the train 10 seconds to travel from one end to the other. To determine the train's speed, we divide the total distance traveled by the time taken. This means 550 meters divided by 10 seconds, resulting in a speed of 55 meters per second. Since we are using distance, which is scalar, the resulting speed is also a scalar quantity. Now, if we use the same formula but substitute the scalar distance with the vector quantity of displacement, we obtain velocity instead of speed. If we know the direction in which the train is traveling, such as east, we can state the displacement as 550 meters to the east. Dividing this by the same time interval of 10 seconds still gives us 55 as the magnitude, but this time the result is velocity, which we express as 55 meters per second to the east. Unlike speed, this includes directional information. It is important to be cautious with the symbolic representation of these formulas as they can be a bit confusing. The letter S can represent different things depending on the context. In the velocity equation, S stands for displacement, while in the speed equation, S refers to speed and D represents distance. In both cases, T stands for time. In practical use, many people apply the velocity formula even when no direction is involved, as this approach allows for the concept of negative velocity, which is useful to represent motion in the opposite or reverse direction. In many real-world scenarios, objects do not move at a constant speed. Their speed might vary throughout the journey. Nevertheless, we can still apply the formula by dividing the total distance or displacement by the total time taken. This gives us the average speed or the average velocity, depending on whether direction is involved. To give some perspective on typical speeds in everyday life measured in meters per second, consider the following. People generally walk at about 1.5 meters per second, run at around 3 meters per second, and cycle at approximately 6 meters per second. However, these figures can vary widely depending on the person's age, level of fitness, and how much effort they are exerting at the time. Moving on to vehicles, a car driving on a main road may travel at about 25 meters per second. A fast train could reach speeds of 55 meters per second, and planes can fly even faster than 250 meters per second. It is not only physical objects like people and vehicles that move at varying speeds, waves do too. For instance, sound waves travel through air at a speed of approximately 330 meters per second, a value that is important to remember. However, this speed changes depending on the medium the sound travels through. For example, sound moves faster in water than in air. Another relatable example is wind, which is essentially the movement of air particles. The speed of wind can range from nearly 0 meters per second on a calm, still day to much higher speeds that may exceed that of a train on a particularly windy day. Wind speed is influenced by factors such as temperature, atmospheric pressure, and the presence of structures like buildings or mountains that it flows around or over. That wraps up everything for this video. I hope you found the explanations clear and useful, and I look forward to seeing you again in the next session.